Oh yeah, we're jumping into the chain rule here. Big time. And very important. It continues to be used throughout all of Calculus 1, 2, and 3. So let's jump into it, and even beyond. So the chain rule is used whenever there is a function within another function. It's also known as composite functions, right? So the way that I think of this in terms of the process is you take the derivative of the outer times the derivative of the inner. What does all that mean? Well, let's say, here's the formal way of doing it, then I'll apply it in a few problems. You've got h of x equals f of g of x. So you've got the outer function is f, the inner function is g. So we take the derivative of the outer, so that's just f prime, without changing anything on the inside. So the derivative of the outer, f prime of g of x, times the derivative of the inner, g prime of x. And when I do this with numbers, I'll explain why this makes a lot of sense. The other way of looking at this, some people write it like this. They think of it as you're doing dy du times du dx. What is that all about? Well, that's if you were to look at it as, and it's an unfortunate letter that we're using for g, f of u. So you're taking the derivative of f with respect to u. That's dy du. And then multiplying by the derivative of u with respect to x. Let's tidy that u up a little bit. And my handwriting's not the best, but I can do better than that. So that gives you du dx. So it's a different way of looking at the chain rule. I prefer this way. Why does this make sense? Take this function, for instance. It has a rate of change, right? It's got slopes of tangent lines. But this function is different than the derivative of just straight up x squared, which is what that outer function is doing. The derivative of this is 2 times x. But that will not be as fast as this function because this function has a 5 on the inside as well as that 6, which will speed up or slow down the function at different times than it would at x squared. In fact, it'll make it 5 times as fast in there. And that's where the chain comes in, that derivative of the outer chained to the derivative of the inner. All right, so you can think of it that way. Of course, it can be proved with the difference quotient, right? The limit definition of the derivative, which we won't do. Without any further ado, let's do the derivative. H prime of x is equal to the derivative of the outside. You're looking at this as if it's just stuff squared. And you're taking the derivative of that. So that's 2 times stuff, which is 5x minus 6. And that'd be 2 minus 1. So you're using the power rule times the derivative of the inside. So that would be the derivative of 5x minus 6, which is 5. That's the chain reaction, the chain rule, or the du dx that's going on in that notation. All we then do is simplify, and that's going to be 5 times 2 is 10 times 5x minus 6. And we could simplify it further if you wanted to. That would be equal to, what would we get? Well, that would be equal to 50x minus 60. And I just want to point out, had we done this by just multiplying by the 2 and never by the 5, you would have just gotten 10x minus 6, which is off by a factor of, 10x minus 12, which is off by a factor of 5, right? So it's that power, that value of 5 that is multiplying everything and speeding up, if you will, or slowing down every tangent line by a factor of 5. All right, enough with that. I think you get it. Derivative of the outside times the derivative of the inside. On to the next one. Find the derivative of each function. We're still finding the functions that give slopes. That's very important here. So we're still just finding the function that gives slopes. So here, we'll take y prime, and that's going to be the derivative of the outside. So that's 4 times everything. Keep everything the same, 4 times stuff to the third. That's the power rule, as if it's u to the 4th, right? And so now that's multiplied by the derivative of the inside, which is 2x minus 3. And we can leave it like that. Some people will want you to simplify. I'm fine with you leaving it like that, especially if you're ever asked to find the slope of a tangent line at a point. That's easy enough to plug into x here. Or to find the zeros of this thing, to find a horizontal tangent line, which we'll do in the future. That's fine there too. So we're good leaving it there. Now I'm going to show it to you done in a different way. Some people will have you write everything as u. I do not endorse this way of doing it, but some people do this. They define this as u, and they do, what is the derivative? They say dy dx is equal to dy du times du dx. So I want to show you how this works in case your teacher teaches it this way, and I'll do it once. The derivative of y with respect to u would be this. That's 4u cubed times the derivative of u, which is, again, u we let equal to x squared minus 3x. So that's going to be, we'll just write it as u prime. And then we plug it in. So that's going to be 4 times u, x squared minus 3x, times u prime, which is 2x minus 3. And you get the same answer. I'm not a fan of this because as problems get more and more involved, setting everything aside as u equal to that, and then needing to find what u prime is, and then plugging it into the process makes for a cumbersome process down the road. Trust me on that, please. Okay, here we go. Here we've got the cube root of x squared minus 3 squared. Not in good shape. We've got to rewrite that. So we're going to rewrite it as x squared minus 3 squared. This is the same as raising it to the 1/3, so that would be to the 2/3. Right? So there's the squared right there, and to the 1/3 power right there. So again, we haven't taken a derivative. We need to do that now. So we take a derivative, which would be the derivative of the outside. So 2/3 times all that stuff. Derivative of the outside, minus 1, negative 1/3, times the derivative of the inside, which is going to be 2x. And we'll smush this together because we can. 2/3 times 2x is 4/3 x. Now that's to the negative 1/3, so some teachers are going to want you to bring that down into the denominator. That's fine, we'll do that in a second. That's an answer. Other teachers are going to be like, yo, dude, you got to bring all that into the denominator. What you doing leaving that up top? Negative 1/3 would be the cube root of x squared minus 3 in the denominator. Okay, that's it. Not bad, right? Okay, one last problem in this video, and then I think you've got the basics of the chain rule down. Then we'll just kind of advance it in a couple more videos. Find g prime of 1. What does your answer represent? I'm going to answer the second part here first. Your answer is going to be the slope of g at 1, because that's what g prime of 1 means. It means find the slope of g at 1. That didn't change just because we're using the chain rule. The chain rule is a different tool we use to find the derivative. Still the slope of the tangent line at a point. This, you could use the quotient rule, but, oh, please try to avoid it. Rewrite that as 8 times 6x minus 5 to the negative 2, and now all we need to do is the chain rule. If you had left it as a quotient, you'd have to do bottom d top minus top d bottom. So you'd have to do quotient and chain rule. No, too complicated. So now we take a derivative, g prime of x, and that's equal to, well, 8's just chilling, times the derivative of this. Ignore the 6x minus 5, derivative of the outer, negative 2, times 6x minus 5 to the negative 3, just using the power rule on this thing again, times the derivative of the inner. So you're focusing your brain now on this and saying, what's the derivative of 6x? It's 6. The derivative of minus 5 is 0, so the whole thing's 6. And multiply it all together. So 8 times negative 2 is negative 16, times 6 is negative 96, and we're going to move that 6x minus 5 to the negative 3 into the basement, man. Okay, let's do it. It's a terrible accent right there. All right, here we go. That's it. Now, is it? Not quite. We need g prime of 1. So we got to plug 1 into this, and then we've got our answer. So negative 96 all over 6 times 1 minus 5. All of that will be cubed. Just plugging 1 into our derivative here, our result. That ends up being negative 96 all over 6 minus 5 is 1. Cubed is just 1. So the slope of the tangent line to g at x equals 1 is negative 96. That's, whoa, that's pretty darn steep. That's like, wah! See you in the next video.